Hey, yeah, let's cover section 5.3. So this isn't going to be a complete detailed hit on this section. My expectation for you is to truly read this section. And I don't say that all the time, but in this case, what they have provided to you in the book, in our textbook, is amazing. I think it's just really, really good. Please take the time to go through. Don't just look at the examples, read the information in between there as well. There's some good pieces that I want you to get. Honestly, this book is pretty darn well written out of all of their books. And so I would suggest it almost with every chapter, honestly. So let's start with zeros. Remember, zeros are the x-intercepts of a polynomial function. Okay. So that's when we're looking for our x-intercept. Zeros are used to determine the local behaviors of polynomial functions, such as terms and the x-intercept. There's many methods to finding the zeros. Factor the greatest common factor. That's the first thing you should always do when you're looking at a polynomial, is to factor out what they have in common. What do the terms have in common? That will make the rest of your job in factoring easier. Factor by difference of squares. So when you see a squared minus b squared, it can be factored into this format. Remember, there's no such thing as the sum of two squares being factored. It is prime, so you cannot do that. So when you see a squared plus b squared, that cannot be factored out. It is truly just what it is. Factor binomial by your chosen method of grouping. Factor quadratic by substitution. Factoring of cubes, we've got formulas for that. And find zeros by zero product property. That'll be the last thing we're going to do. So we're going to find zeros of the following polynomials. So the first one here, I see x to the fifth minus x to the cubed. What do they have in common? Because there's something they have in common that I want to pull out of there. They have x cubed in common. To find the zeros, what do we have to do? We have to let y equal 0, or f of x equals 0. So let's do that first. All right, we've got x to the fifth minus x cubed. They have x cubed in common. So I'm going to factor that out. When I factor out x cubed from x to the fifth, that leaves me with x squared minus 1. X cubed times negative 1 is negative x cubed. All right. So I'm going to set this equal to 0, x cubed equal to 0. Take this binomial and set it equal to 0. And I'm going to solve for x. For this one, it's x cubed, so I'm going to take the cube root of both sides. So x equals 0. Now, x equals 0 is actually 3 times. So that's going to be, it's 3 times that. It's, sometimes there's double, sometimes this is a triple. So x equals 0 is representing 3 of those degrees from this polynomial. From this one, there's 2 different ways we could factor this. I see it as the difference of 2 squares. So x minus 1, x plus 1, set each of those equal to 0. And solve for x. Add 1 to both sides, x equals 1. Subtract 1 from both sides, and x equals negative 1. All right, so these are all of our zeros. The other way we could have factored this, the x squared minus 1, I don't expect you to do both, just in case you think of it this way instead, is to move the 1 over. So you get x squared is equal to 1, and then take the square root of both sides. Remember, on this side, you have to go plus or minus. So x is equal to plus or minus 1. So you could have this and x equals 0, or you could have these 3. Again, you can write these out as 0, 0, comma 1, 0, or negative 1, 0. However you would like to write it. Okay. And that is the zeros for the polynomial. Let's look at the next one. First thing I would have to do is put this equal to 0. So I'm going to rewrite it over here. X cubed plus x squared minus 20x equal to 0. They all have x in common, so I'm going to factor that out. X squared, x taken out of x cubed is x squared. X taken out of x squared is x. And then take an x out of this one, it's negative 20. All right. I can either factor this, continue factoring this, or I can just set them each equal to 0 and solve. Gosh, this is the next, y'all. I'm working on it. X and x looks like a 5 and a 4, negative and positive. All right, now I just need to take each of these and set them equal to 0. X equals 0, x plus 5 equal to 0, x minus 4 equal to 0, and solve for x. So there's 1. Subtract 5 from both sides, x equals -5. There's 2. Add 4 to both sides, and x equals 4. There is 3. We had a degree of 3, so it makes sense to have 3 zeros. Okay. The next one, 2x to the 4th minus 6x cubed minus 20x squared. I need to set this equal to 0. So 2x to the 4th minus 6x cubed minus 20x squared equals 0. They all have a 2 in common, and they all have an x squared in common. So I'm going to factor that out. 2 from 2 is 1. X squared from x fourth is x squared. All right, minus 2 times -3 is -6. X squared from x cubed is an x. Minus 2 times -10 is -20. And then that is it for the x squares. All right, I can keep going on this. 2x squared, factor this bad boy out. X, 5, 2, negative, positive. Set each of those equal to 0. X minus 5 equal to 0, and x plus 2 equal to 0. All right, divide both sides by 2. X squared is equal to 0, square root of both sides. X is equal to 0. Counts as 2 of them. All right, the next one, I add 5 to both sides. So x is equal to 5. There's my next one. Subtract 2 from both sides. X is equal to -2. And there is the last of my zeros. All right. Ooh, this one's a fun. I like these. So these, we have to look at them in 2 different formats. I look at the first one and say, okay, what are these? I need to set them equal to 0 first. 2x cubed minus x squared minus 8x plus 4 equals 0. All right, now I just look at these first 2 and I see, what do they have in common? They have x squared in common. So I'm going to factor out x squared from just these 2. And when I do that, I'm left with 2x minus 1. Okay. 2x times x squared is 2x cubed. X squared times -1 is -x cubed. Now I'm going to come over here and I'm going to make this one, I'm going to have something that comes out and looks 2x minus 1. That's my goal here that I want to do with this. So I'm going to have to factor out -2. Because then I would have these exactly the same. I'm sorry, -4. I'm losing my mind. 4, -4. 4 times 2 is 8, and there's our x. And then -4 times -1 is +4. So that works out perfectly. All right, now we have to look at it this way. We've got a term here, and we've got a term here. What do these 2 terms have in common? They've got the 2x minus 1. And we're left with, when we factor out 2x minus 1 from this term, we're left with x squared. And when we factor out 2x minus 1 from this term, we're left with -4. Okay. Couple different things we can do here. I can set these both equal to 0 now, or I can keep factoring this one. Because it's the difference of 2 squares. Now I set them all equal to 0. And solve for x. So add 1 to both sides, left with 2x equals 1. Divide both sides by 2. X is equal to 1/2. There's a 0. Add 2 to both sides. X equals 2. And then last, subtract 2 from both sides. And we're left with x equals -2. All right. Let me know what questions y'all have regarding that. Next one. I've got x to the 4th minus 8x squared plus 12. For this one, we're going to let u equal x squared. It's just equal to the x squared, which is your middle term. And when I do that, I can replace the x to the 4th with u squared minus 8u plus 12. And I'm going to set this equal to 0 because I'm looking for my zeros. I can now factor this U and U. 12 can be, it's 4 and 3, 6 and 2. 6 and 2. They have to both be negative because only the middle term is negative. Now I can set these equal to 0. U minus 6 equal to 0. U minus 2 equal to 0 and solve for U. U is equal to 6 and U is equal to 2. We added 6 to both sides, added 2 to both sides. Now I'm going to substitute back my x squared where the U is. X squared equals 2. All right, now we're going to solve for x. We're going to hit the square root of both sides, plus or minus the square root of 6. So x equals plus or minus the square root of 6, square root of both sides. X is equal plus or minus the square root of 2. Those are our answers. Those are our zeros, and there's 4 of them. 1, 2, 3, 4. We have a degree of 4, so that makes complete sense. Okay. All right. One more factoring. They don't have anything in common. I do see that I've got some larger terms here that I don't necessarily want to play with. I mean, you could, if you want to just factor these into 2 parentheses, you can. But typically we teach this is let U equal the middle term variable and exponent. U will be equal to x cubed, which is the variable with its exponent. So we can replace this needs to become 0. So U to the third, no, U squared, is U squared and U third, minus 7U minus 8 is equal to 0. Factor U and U, 8 and 1, negative and positive. All right, so U minus 8 is equal to 0. U plus 1 is equal to 0. U is equal to 8. U is equal to negative 1. And now I'm going to replace my U with x cubed. I don't want to do it here. That's not going to look as good. That's not going to work for me. I can't do it this way. I can't do it this way at all. I want to change this. I want to do my x cubed here. I'm sorry. X cubed minus 8 is equal to 0. And x cubed plus 1 is equal to 0. And this is why I want to show you. So let's replace it before we solve for U. I want to go back and look at that other one to make sure there's not anything else you could have done. I'm going to go look at that here in just a second. But let's finish this one. The reason I saw that we can't do that is because there's a cube. If it was a square, that's different. But we can't just go through and take the cube root of both sides. It's not going to work as pretty. What we're going to have to do here is we've got the difference of 2 cubes. X cubed, and 8's the representation of 2 cubed. All right. And we have a formula that we can follow. X minus 2, x squared plus 8, I'm sorry, plus 2x plus 4. There we go. So this is x minus 2 equal to 0. And x squared plus 2x plus 4 equal to 0. This is x equals 2. And this one, we can't factor. You can't factor this at all. So what we're going to have to do for this one is the quadratic. And I'm out of paper. I'm going to pause real quick and grab some more paper. I didn't realize I was going to do all this fun stuff. It's kind of exciting. Okay. So we've got x is equal to 2. And we have this trinomial equal to 0. We need to solve this using the quadratic equation. It's just probably the easiest way to do this. So A is 1, B is 2, C is 4, negative. So x equals negative B. So negative 2 plus or minus the square root B squared minus 4 A C. And all of that is over 2 times 1. Glasses. Okay. So that's negative 2 plus or minus the square root. 2 squares 4. 4 minus 16 over 2. This becomes what? Negative 8. No, I'm sorry. Negative. X equals negative 2 plus or minus the square root of negative 12 over 2. You're getting some algebra out of this one. My gosh. This can break down into 4 and 3. So we've got, this is going to become an I, and it's going to be the square root of 4 and the square root of 3. So that's 2I, the square root of 3. That's going to become -2 plus or minus 2I square root of 3, all this is over 2. To make it easier to reduce this, you can just make it -2 over 2 plus or minus 2I the square root of 3 over 2. Because here's the deal. This has got a complex number. This is a complex number. So you have to answer in A plus BI format. So they have to be separated. And if they share a denominator, you can just easily just see that it, well, you could have already seen that it reduced. Plus or minus I squared of 3. So there are 2 of your zeros, which are complex numbers. And then we had x equals 2. And I think that's all we ended up with. Oh, we're not done. We have this one over here to deal with as well. So that's 3 so far. This should come up with another 3 because it's got a degree of 3. It's the sum of 2 cubes because this is x cubed plus 1 cubed equal to 0. So we can create our trinomial is x plus 1, square the first, multiply them together, and then square the last. Oh, this should be a subtraction sign. This should be subtraction. There we go. All right, then we set each of these equal to 0. So x plus 1 equal to 0 is just x equals -1. There's that one. Now we're up to 4. This is not going to factor nicely because it's difference of 2, sum of 2 cubes. So what we're going to have to do is Pythagorean again. So let's go a equals 1. B equals -1 and C equals 1. Okay, that should be weird. X equals -b, so -1 plus or minus the square root of b squared, -1 squared, minus 4 times A times C. All of that is over 2 times A. My goodness, I need more space. Now I'm going to lose this. I'm going to rewrite this real quick for y'all. X equals, I'm going to change it to negative times negative is a +1, plus or minus the square root of 1 minus 4 times 4, and all that's over 2. Okay. Let's get this where we can see. So that's x equals 1 plus or minus square root of -3, right, over 2. X is equal to 1 plus or minus I square root of 3 over 2. And then let's just put this in the correct format, A plus BI format, which you have to do with complex numbers to where this is 1/2. And you can have plus or minus I square root of 3 over 2, or you could write them out separately should you want to, and that would be 1/2 plus I square root of 3 over 2, and 1/2 minus I square root of 3 over 2. Either one, I'm cool with this. So that's 2 of them, 3 of them, and then we had, no, that was back here. 3 of them, 4, 5, 6. That's what it was. Okay. So we found all 6 of the zeros. That was some work. All right. Let's learn how to graph polynomials. All right. Factor and find the zeros and multiplicities of each zero. So we haven't even talked about multiplicities yet. We're about to do so though. Even multiplicity means that the graph touches or is tangent to the x-axis. It means it doesn't go through it. All right. If it goes through it, then that's not an even multiplicity. It would need to bounce off the x-axis, either from the top or from the bottom, and I'll show you more about it. Odd multiplicity means that the graph intersects the x-axis. All right, determine the end behaviors, determine symmetry, and then find the y-intercept. Okay, we've got some things to do here. I might need some more paper. So we're going to factor and find the zeros and multiplicity of each zero. First thing we're going to do, and I'm going to use some space up here. All right, for my zeros, this doesn't have an x with it, so I ignored that. I only deal with my x minus 3. So I'm starting with my zeros, and then I'm going to have multiplicity. And then I want to have symmetry. Let's answer those. Our zeros are going to be taking x minus 1, I'm sorry, x minus 3, and setting it equal to 0. Well, when you solve for x, you add 3 to both sides, right? So plus 3. So x is equal to 3. There is one of our zeros. The multiplicity for this 0 is even because it's a 2. All right, it's even because the exponent is a 2. Even multiplicity means the graph touches or is tangent to the x-axis. All right, so it's even. So that means it bounces. All right. What else could we want to know? Determine symmetry. Okay. Well, if it's even, then it is symmetric about the y-axis. If it's even, it's symmetric about the y-axis. Symmetric about the y-axis because even. Okay, this is all having to do with this one. We'll do end behavior at the end, but because that has to do with the whole thing. The next one is x plus 5. So we take x plus 5 and set it equal to 0. Notice we didn't take the square when we did this. We just took the x minus 3, what's inside the parentheses. The 2 decides our multiplicity, which decides our symmetry. So right now we're just taking the x plus 5, set it equal to 0, and we get x is equal to negative 5. That's the next place it's going to be, that's going to be our next 0. So this is going to be our next x-intercept. All right. Here's the gig. This is odd because the degree is odd. All right. The multiplicity is odd. So multiplicity is odd, and therefore it intersects the x-axis. Intersect. All right. And then symmetry is for odd. We've talked about this before briefly. It's symmetric about the origin. About origin because odd. You need to know why, not just which one. All right. What else? We can now graph it. What's our end behaviors? How do we decide that? We did symmetry. We haven't found the y-intercept yet. We can do that. Let's find the y-intercept. I'm going to just take up some space here. So y equals, or f of x equals, same thing for us, -2. And then everywhere there's an x, I'm going to put a 0. And solve for y. -3 squared is 9. Positive 9. And then 5. 45 times 2 is 90. So y equals -90. So that's our y-intercept. We can start graphing this. I'm going to have to choose something crazy since it's -90. I'll say 90. Let's do these by tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put, there's our y-intercept at -90. Oh, that's not -90. 10, 20, 30, 40, 50, 60, 70, 80. Oh, that's wrong. That's -100. So it needs to be right here. That's wrong. All right. So there's our -90. What else do we need to know? What's our leading term? We can use that. And we've got some x, we've got our zeros. Zeros are at 3. So 1, 2, 3. And what's the other one? -5. 1, 2, 3, 4, 5. So here and here. But what's happening at each of these? At 3, it's even, so it's bouncing. But I don't know if it's bouncing this way or if it's bouncing this way. X is -5, it's odd, so it's going to go through that one. Going to go through that one. So I'm going to hold off on the 3 until I see what my leading term is to decide the directions of my arrows for my end behavior. So let's find our leading term. -2, leading term is -2, and then it's x squared and x, which is -2x cubed. Okay, so we have a negative number with an odd exponent. What does this look like? Looks like this. Okay, so that tells me from this is going to go up. All right, so this is going to be coming down and probably going through my 90. It's going to be going up like this. All right, and remember this is sketching, so it's not going to be exact. Now, the other thing is that also tells me that my other arrow needs to end up being going down over here like this. So that means where 3 is even, my bounce is going to be like that. So it's going to bounce there, and then it will follow through over here. All right, those are all the different things I was able to get from the zeros, the multiplicity, and the leading term to help us decide, along with the y-intercept, to help us decide what this was going to look like. And that's probably a pretty good sketch of it. If you wanted to put this in Desmos or your calculator to see, it should provide something that looks relatively similar to this. All right, let's go to the next. Do the same, what do we have to do all of these? Oh my gosh, that's a lot. Oh, we just need to sketch the graph. Okay, well, we still need to do pretty much all of this. So I'm going to go a little bit faster this time. I'm going to get my zero, my multiplicity. I'm not going to look for my symmetry this time. You've got your example for that. So I'm going to go x plus 1 is going to be x equals -1. And that's an odd multiplicity because the exponent's 1. X plus 3 is going to give me an x equals -3, 0. It too is odd because it has an exponent of 1. And then x minus 4 is going to give me x equals +4, and it too has an odd x multiplicity. All right. The next thing is, what's my leading term? My leading term is 8 times x times x times x cubed. So that is 8, 1, 2, 3, that's 8x to the 5th. So it is a positive with an odd exponent. All right, so it's going to look something like this. Positive and odd is going up here and down here. All right, somewhere in between there's going to be some wiggling because it's going to be crossing over at -1, -3, and 4. So just to show you what the end behavior is going to look like, let's go a little bit further with this. So I've got -1, -3, and 4. 2, 3, 4. And they are going through at all of them. There's no bouncing. It's intersects at all. Intersect. Because they're odd. It bounces if it's even. Okay. So my end behavior, I see that I'm going to be going up over here and down over here based on my leading term. So that means I'm going to look something. Oh, I haven't done my y-intercept. Let's do that real quick. So g of 0 is 8 times 0 plus 1, 0 plus 3, 0 minus 4 cubed. It's going to be 8 times 1 times 3 times 64. And it's negative. All right. 1536 is your y-intercept. So again, some crazy, I'm just going to put -1536. We'll just assume that that's where it's going to go through, right up there. But somewhere up here, it's going to turn, and then it's going to have to come down here, go through the y-intercept, and then it will go somehow up through 4 and then continue on. That's my sketch of what this little guy is going to look like. All right, based on the information. Let's do our next one. We've got, let's do our zeros. Zeros, multiplicity. You will have to do this on the test. I will ask for it. So x plus 2, I'm going to set equal to 0, and that's x equals -2 with an odd multiplicity. Oh, I forgot one. I've got this guy right here. This is x equals 0, because if you take -4x cubed and set it equal to 0, and you solve, divide both sides by -4, and that's x cubed equals 0, and then you try to take the cube root, and it's just going to be x equals 0. So let's put x equals 0, and that's got an odd as well. So these are intersects because they're odd. And the last one is x minus 2, so that's x equals 2, and that's even. So that's a bounce. Intersects and intersects. But next thing we need to do is find the leading term for this. We've got -4x cubed. This is the LT. We've got 1x times x, and then times x squared is -4x to the 3, 4, 5, 6. All right, so it's negative and even. So that's going to be like this for the end behavior. That should kind of help with that. Okay, so let's get our graph going. Oh, y-intercept, one more thing. Y-intercept is what? H of 0, -4 times 0 cubed, 0 plus 2, 0 minus 2 squared. The 0 wipes everybody out. So it's going to go through the origin. That's the y-intercept. Okay. 0 cubed is 0, times -4 is 0. 0 times 2 is 0. 0 times -2 squared is 0. So it's 0. All right. And then we're going to have to go down and down for our end behaviors. What else? We've got x is -2, 0, and 2. So we've already taken care of the 0. -2 and 2. All right. And for -2, it's odd, so it's intersecting. For 0, it's intersecting. And then at 2, it's bouncing. But I need it to continue down this way. So it has to bounce like that. All right. And then it's going to have to do some kind of a wiggly thing to go up and go through here, because it's odd at 0. And then it's odd at -2. So something like that is the behavior that's happening here. Okay. I don't know how far it's dipping here. I don't know how high it's dipping. It's going concaving up that way. So, but we have our arrows for end behavior going the same. And what is this end behavior? What does this look like? This is as x approaches positive infinity, f of x is approaching negative infinity. As x is approaching negative infinity, f of x is approaching negative infinity as well. You're going to end up having to write stuff like this on the exam. Please make sure that you're comfortable with it. In fact, you might want to go back and do the same thing for the ones that we have not done. That's the end of 5-3. Let me know what questions you have. We only have one more lecture, and then we're prepping for exam. Let me know what questions y'all have. Don't get behind.